Hello students, welcome to our first lesson in computers and logic. We're going to be talking about bytes, bits and nibbles. So let's start off here by asking ourselves a question. What do you think of when you hear the terms bit, byte, and nibble? Well, if you're someone like me who tends to think about food a lot, it immediately makes you hungry. But these terms are not food related, they're actually terms that are used in computer science to describe certain data types. Yes, computer scientists have a very weird sense of humor. You'll see this happen in numerous subjects. In this lesson, though, we're going to explore what a data structure is and what these terms actually mean. So let's first ask ourselves, what is a data structure? And a data structure is simply just a way for us to organize data into computers so that it can be used efficiently. I mean, it doesn't do as much good if it's just kind of haphazardly thrown around. It needs to have some kind of structure. And those structures vary in implementation and complexity. I call them primitive data types here in the lesson, but they're not necessarily just primitive. Primitive is just the word I kind of use. They're more like basic types here that we're talking about with bits and bytes. Primitive is not actually the right word to use for primitive. Usually refers to things like chars and strings, or even like ints. But what we're going to be talking about are bits and bytes. But I'm just using the word primitive right now because it's a word that people will understand without getting confused. Even though, again, it's not technically the right term to use. There are some types, such as bits, though, or excuse me, bytes, and larger, more complex structures that exist, such as arrays and lists. So, depending upon the programming language you're using, or depending upon what system you're going to be working in, these different forms of structures have different complexity, and how they get implemented into the system varies. Now, most assembly and low-level languages lack support for data structures, so things like assembler, or if you look at just like binary hexadecimal, there's no such thing as data structures. Just cool. As such, data structure are typically found in higher level language only. Like you'll see them a lot in like object-oriented languages, for example. You will see a lot of support for things like in Java you have bytes. Bytes are of course composed of 8 bits, which we're going to look at more here in a second. But those bytes can then be composed into other primitive types such as char, int, boolean. Alright, so let's look at those primitive types. Right? These are the basic building blocks for a programming language. Now, this is the true primitive data type. It's not just like bits and bytes. This is the true primitive data type. Right? And these are our classic primitive types that we get talked about. So whenever you hear me talk about primitive types, this is actually what I'm talking about. So a character, or sometimes known as a char, which is pretty much any letter or character that's on your keyboard, is a char. Technically, even the numbers are chars or characters. Integers, we have ints. Now those are actually, again, those are the numbers on your keyboard, but in this case they're not being represented in the computer, because the computer actually represents both, you have both the number 1, which has the value of 1, and then you also have the character 1. It can be a little confusing to understand, but they're two distinct things. You have floating point numbers, such as float, that's, usually gets into things like your decimals, so like 2.5 would be a float. Boolean, which is true and false values. So you're pretty much when you're testing a condition to see if something is true. Like let's say I want to see if 3 is greater than 2. We know that's true. You can use a Boolean though to test that. And then lastly, we have what's known as a reference or a pointer or a handle, depending on what programming language you're using. And that's usually used to call back to the location of an object where it's stored in memory. All right, let's talk a little bit more about these units of information. So commonly, storage information is represented using a bit. A bit represents, of course, 2 states, on or off. Now, some of you might recognize this as a binary state, binary meaning that there's 2. And here, on/off is typically represented with a 0 and a 1. 1 meaning on, 0 meaning off. Additionally, a byte is used to represent 8 bits. This storage of 8 bits is also sometimes known as an octet. Those you might remember geometry, octagon. What's the root prefix? Oct, meaning 8. So octet is really just a fancy way of saying 8 bits, which we would just say a byte. Now, a byte has 256 distinct values. And when I say 256, that means I'm typically going from 0 all the way up to 255. And you can't say 0 to 256 because that's 257 values. So it's 0 to 255. Whereas when we talk about a bit, it's just one value, 0 or 1. A byte can be anywhere from 0 all the way up to 255. All right, let's talk a little bit more about those bits. All right. So a bit is just simply a portmanteau of binary digit. Took the term, kind of crunched down, made bit. Now, as mentioned previously, we did say that it represents two states, commonly represented as 0 or 1. And in Carl Babbage's analytical engine, a state was physically represented with a mechanical gear lever. So pretty much if you wanted something to go, you would push the lever up and something would happen. If you wanted it to stop, you'd pull the lever back. Today, though, we don't represent that with levers, and there's no levers or gears inside of your computer. Instead, we use changes of voltage to represent this change. A higher voltage is typically represented with a positive or a 1 value. And when I talk about positive here, I'm not saying it's a positive number. Usually, when you look at voltages, there's always going to be some kind of voltage flowing through the circuit, unless there's no electricity going at all. And the small values are something like very, very minute. That's typically actually your 0 value, whereas something that's larger is your 1 value. All right, let's talk a little more of these bytes. As mentioned previously, a byte is composed of 8 bits. Historically, a byte was the number of bits needed to encode a single character of text. So again, going back to our keyboard, any of those keys that you see there was a single character. So if I wanted to do the letter A, that would be represented with 1 byte, or 8 bits. And it is for this reason that a byte is usually what is the smallest addressable memory in computer architectures. Excuse me. Architectures, if I can speak the word. Byte is also purposely spelled byte instead of byte in order to avoid accidental mutation from the term bit. If you notice, we purposely misspell it, B-Y-T-E, instead of B-I-T-E, like it normally is in the English language. And that's because it wouldn't take that much to go from B-I-T-E to just B-I-T. We could accidentally leave off a letter or something like that, and it would be two different things. So in order to avoid that from happening, to get any confusion like that, they purposely misspelled byte, and so that is how we have the term used in computer science. Now, there's one other term I need to talk about, which is that of a nibble. All right. I mentioned in the beginning there's byte, bit, and nibble. All right. A nibble is related to bytes in that a byte is 8 bits. However, the unit that is called a nibble is half a byte, or 4 bits. A nibble has 16 possible values and is represented with a single hexadecimal value. And again, don't worry about what hexadecimal is. I'm throwing out some of these terms here, but don't worry about it yet. Just know that that's what it is. All right. A full byte is 2 hexadecimal digits and often represented as 2 nibbles. All right. You don't really need too much other than the big thing you probably will want to know about it is that a nibble is a half a byte or 4 bits. All right. That's the big thing that you need to take away from this screen right here. That a nibble is half a byte or 4 bits. And that concludes our lesson, folks. Until next time.